Okay, 8G5. This is 8th grade geometry, standard 5, video 3. Today we're going to be talking about angles and polygons. We're going to be concentrating mostly on getting the sum of interior and exterior angles of given polygons. Few terms to know. I'd like you to copy these down and put these in your journals. Okay, the first thing we have here is a rule for finding the total amount of interior degrees in a polygon. So I guess we can always talk about a triangle. A triangle is very famous for having 180 degrees, and a quadrilateral has 360 degrees. So those are pretty well known, and we're going to get into multi-sided or many-sided polygons. Some of the specifics you probably heard of, like pentagon, hexagon, heptagon, octagon is very famous. And we're going to find out how many degrees are in all of those different types of polygons. And here you see a rule, n minus 2. N represents the number of sides of the polygon, if you want to write that down. So n is the number of sides on a polygon. And you're going to subtract 2 from the number of sides, and then that total, you're going to multiply that by 180 degrees, and I'm going to show you why that occurs. All right, so I talked about a triangle, and I talked about a quadrilateral. This happens to be a rectangle, and why the 360 degrees or why the 180 degrees. So let's start there. In your rectangle, it's common, these boxes represent 90 degrees, and if you're thinking why are those 90 degrees, they're considered to be right angles, and they come off of these lines. So I'm going to extend my top line, and it forms what you see, a supplementary angle, and we've talked a lot about supplementary angles. So if I were to do that to the top line, the side lines, and even the bottom line, these are all straight, which means they have 180 degrees. So if I have one of the interior angles being 90 degrees, that would make the exterior, which we're going to talk again later about, is the exterior angles, which is 180 total degrees. So if I were to draw a box on the outside, we know that when we add our 4 90-degree angles, I guess I could call this 1, 2, 3, 4 90-degree angles on the interior. Here we have 360 total degrees. Now when you're looking at triangles, where does the 180 come from? Well, if you take this triangle and duplicate it, rotate it, and then connect your pieces, what type of figure do you have? Good, you have a quadrilateral. And what we noted on the bottom, if it has 4 sides, we know that we have a total of 360 degrees. Now, even though this isn't a rectangle, it still has 4 sides, which means it has 2 triangles, and each triangle is 180 degrees. And when you put those 2 triangles together, you get a total of your 360. All right, now what happens when we add an additional side? So our quadrilateral was just given an additional side length, line segment, and it added this 5th line. All right, so if you count them out, you have 1, 2, 3, 4, 5 side lengths. And I want to know how many degrees are on the interior. So all of these little angles that you see in here, they all appear to be obtuse. How many total are inside? Okay, so according to our formula, we know that it said take n minus 2, n is the number of sides, which is 5, take 2 away from it, and then whatever that total is, multiply it by 180 degrees. So let's work that out. We have 3, and then if you want to figure out on a calculator, which we don't really use anymore, but if you can do some longhand multiplication, we have 180 multiplied by 3, which would give you 540 degrees. All right, now why this formula? Okay, so the thought is we can take one of our vertices, one of the points at which our line segments meet, and we can create these diagonals. So I'm going to create a few diagonals here for you. I'm going to choose one of my vertices, one vertex, and I'm going to draw a diagonal to another one of our vertices. Okay, now how many of those am I able to draw here? Okay, so I see one diagonal. I can take, you have to take the same vertex and draw an additional diagonal. And that's all you can do. You can't draw any more diagonals because the angle that's adjacent to the starting angle that we began with, our vertex, it would end up being, if I drag this third diagonal over to the adjacent angle, it's going to be the same line. See how it just kind of snapped right into there? So you're not drawing anything new. It's still that same line segment on the side, and it happens over on line segment 2 also. So that's where we lose our two sides. That's why we have n minus 2, because we're not counting those two sides that are connected to our original vertex. So why the 180 now? You could probably see it as we drew our diagonals. We have a triangle here, which is 180, a second triangle, and a third triangle. So that's why we have 3 multiplied by 180 and 540 total degrees. All right, now the next part says, what if we have a polygon that we want to know exactly how many degrees each angle is? So we don't want to know how many there are in the total polygon. I want to know each one of these separate angles. And this only works for regular polygons. Now a regular polygon, it's one of your terms you need to know. It's on page 2. A regular polygon means all of the line segments are congruent to each other. So if this line segment measures 9 inches, that means all of these other ones are 9 inches also, hence these little tick marks, we call them. And then the other rule to a regular polygon is that all of these angles must also be congruent. Now I didn't draw this picture to scale, meaning I didn't draw perfect 9-inch lines or whatever your measurement was. I'm just letting you know by these tick marks and angle arcs that this is a regular polygon. So if it's regular, we're going to use our new formula. So you're going to take the number of sides. So our numerator is like our last formula. So we're going to take the number of sides, which in this picture, it's 1, 2, 3, 4, 5, 6. 6, take away 2, multiply by 180, and then you're going to divide by the number of sides again. All right, so let's see here. We have 4 multiplied by 180 divided by 6. Well, 180 times 4 is 720 degrees divided by 6. And what are you going to get there? How many would each one of those be? So you take out our calculator here. We go 720 divided by 6 is 120 degrees. So what they're saying is every single angle, since it's regular, will be 120 degrees. And when you add them all up, you should get, what, 720 degrees, because that's how many degrees are in this particular polygon. All right, so now we're going to find the measurement of the exterior. So these are the angles on the outside of your polygon. And the only way to do that would be to take these line segments and extend them outwards. So let's grab this one down here. We're going to extend each line segment outward. And we know that these lines are 180 degrees. And that is going to bring back this idea of supplementary angles. So let me label these. We have 1, angle 2. These are my interiors. And now let's look at our exterior. So I have one up here that's obtuse. This one is acute. And this one is obtuse. So playing along with this idea of supplementary angles, if we know the measurements of the interiors, very quickly we could use this supplementary rule to get the exterior angles. And I have a problem set up for you here. All right, so 3 lines, it's a triangle. 3 segments can be extended outward. So I'll take this one and extend it. I'll take the second one over here maybe and extend it left. And then I have this one coming downward and I'll extend it here. Okay, so just looking at them, I'm sure you could figure out this 101 degrees supplement. Well, 180 degrees subtracted by 101 leaves you 79 degrees for the first exterior angle. The second one, I have 47 degrees, and if I want to find the supplement to that, I can take 180, subtract 47, and what do we end up with? We have 3, so we have 133 degrees in my obtuse angle. And then the final one, 32 degrees, I need the supplement. So here's an acute, and I keep it coming all the way over here. So what's the measurement of my third exterior angle? Same thought, 180 degrees subtracted by 32 degrees. All right, so we have 8, 4, so we have 148 degrees. Okay, in your journals, I'd like you to define the given terms on page 2 of the flip chart and write a few sentences on what you think you learned from this video, and mark anything in your notes that you think is troublesome to you. Maybe you had a difficult time understanding what I was showing you, and bring those questions to class and we can answer them together.